We'll see how to do meshing in Pointwise for external flow. Um, so let's open the software. So first thing is to import geometry. I will go to File, Import, Database. So database is basically the information about geometry. So it is the geometry. So I'll import the SolidWorks file. Open. So as it is compatible to many different CAD softwares, so this won't be an issue. So I'll check the units. I will keep the unit as it is from the file, or else we can change if we need. So it's importing the file. So here it is, but it is not really visible. To visualize it, we'll select all. We'll go to this symbol and click on the shaded. Now it is quite visible. Okay, so on the left side here we can see that there we have only database right now. We don't have any connector domains or blocks. So for that, uh, we will first select. Okay, before that we'll go to the defaults and we will change this value as whatever we like. Like for this case, we will keep it as 0.4. So basically, it's the distance between connector is like a edge. So 0.4 is the distance between the node. That's the average distance, and we can change that for further refinement if we need. And here we will check the unstructured domain. And okay, that's it. Now we will select all. We'll go to the create button and here on database entities. First, we can also click on this unstructured. I'll select again here, create on database entities. I'll change this connector joint angle to some 10. So it is like if the angle is less than 10, it will create another connector. Now I will click OK. Let's see if it generates anything for us. Okay, so is the mesh. It is quite not that much visible. So to visualize this, I will go to view. I will turn off the database. It's quite visible. Okay. But it's not that great, I would say. It's not refined here, and it's a little bit coarse type of mesh, but we can play with it. Now let's suppose we need some structured mesh here rather than unstructured. What I will do, I will just delete this domain. Also, from the bottom, we need some kind of structured domain. So I'll delete that also. Now to create the domain, I will click this edges, but currently I'm unable to access that. So I will switch, turn off this mask and only select, only toggle the connector mask. Now I can select the edges. So I'll click the edges, all the rectangle, and now I will click on the structured mesh and generate the assembled domain. So here you can see this is a structured mesh. Similarly, I can do this for the bottom plane. I'll click on this. I'll click on structured. You're already clicked. I'll do this. Okay. Let's suppose if you want, if you change this refinement, we can click on that. We'll change that also. We'll click opposing edges. and we can change it to some like 100. You can see this refinement, or we can change more to like 500. It's more refined, but this is 500 and this is not. So let's change this also. Let's put it somewhere around 300. You can play with it. See, this mesh is also changed. So a little bit refinement is done. And one more thing is like here a little bit mesh is coarse, but that is okay. Now here we need some kind of refinement because that's the important part of it. I will change this to some, let's say 300, kept as it is, an unstructured mesh like here. Okay, it's not changing anything. Let's see. I change it to structured. Six hundred. Okay, it's refining that mesh. Okay, it's refined at the boundaries. But now we need something uh, refined here, which is not currently. It's very coarse mesh. So what we can do is we can select all connectors where all the connectors are selected, and now here I can play with it. It's like if I click on 50, let's see how what it gives. Mesh, and I think we can just proceed with it. Okay, it's taking a little more time because uh, this dimension is very less, and I refine it very much. Let's wait for that. I'll just pause the video. Where the refinement has been done, you can see it's a little bit, I would say, more refined than it should be. But yeah, yes, we can play with it. That's my point. And let's say if we want some kind of controlled refinement here and not on the other part, what we can do is we can just select this spacing constraint, and we'll click on this three meeting points. So that this is the node, and we'll change this to some, let's say 0.3. We'll see what will happen. Okay. So basically, that was a coarse value. So you can see this. Here is the finer. This is a coarse. But for us, we need some kind of refined surf refinement here rather than coarse. Right, correct. It's good. And we can actually select this edge also. and this is also, and we'll keep it as a 0.005 so that we'll be having uniformity. Okay. So here the mesh element size are less, and here they are coarse, but we need some kind of refinement here also. So we'll do that. So now we'll change to like something like 0.005 again. Let's see how it looks. I'll stop recording, pause the recording, and let's see. Okay, the refinement has been done. It's quite finer mesh on this side. It goes to the coarse, and again it's finer at this edge. I think it's good. Means we can play with it. I mean, if however we want, we can do that. You can also see this mesh is not quite good, but we can, for now, we can just use this. And now surface meshing has generated, and now we'll go for, let's say, uh, volume mesh. So to do that, I'll just, okay, I'll switch on this mask, click on all the domains, go to the create automatic volume. The first option, create volume mesh boundaries, I'll click here. Okay, it created a domain for us. Here, let's see, we want some kind of voxel volume mesh like SnappyX. Uh, we'll keep a rectangular shape, and okay, we'll change it from the extreme ends. So basically W2 is 0 because if you see the advanced setting, here the symmetric planes are Z plane plus Z, and for now, okay, let's reduce the domain size. For L1, I will keep it as 2. Okay, it's changing, so I'll unlink that. For L2, I'll keep it as like a 12.5. That's 2. And from W1, I'll keep it as a 4. All are in meters. And for H1, I'll keep it as a 3 and 3. So is our domain. Boundary layer we can turn on. And let's keep all the things as it is and create our mesh. Okay, it only took a minute to generate this mesh. Now we'll click on OK. So here you can see it's better work. I'll just click on OK. And here the cell count is there, estimated cell count is there. Now the next thing is to initialize this mesh. Here the block is generated. You can see. I'll click on this block. go to the grid and then solve. Here you can change all the attributes, size field, T-Rex, and all the things. For now, we'll keep it as it is and we'll initialize this. Now it is initializing for us. Let's wait, complete it. I'll again pause the recording. So as it took a little more time than because of the finer mesh, I opened another assembly, similar assembly. So how it looks after the refinement, after the initializing the mesh, it will look like this. So if you go to the CA grid and see the cell count, here it will give the total cells. It's around 5 million. And if you want to see the mesh cut section of the mesh, we'll select all, we'll go to the examine, and then we'll go to the volume. We'll say enable cutting, and here you can see the skewness also, what is the maximum value and where that is located. See, you can see the later meshing, how it is, and then there are other parameters also. So see, where is the minimum edge length? So you can refine that particular area or do the operation for that later on. But yeah, and also the best part is, like, if you go to the advanced and check about the histogram, you can see how it looks. Look at the histogram. So this is all it is. You can always play with the number of mesh. There are many factors we can play with that and uh, get the required meshing. And yeah, the last step is to export the file. In other video, I exported in open form. Now I'll select ANSYS Fluent as a solver, and here we can also create the mode boundary conditions. And I have already created the boundary conditions for this, and here it is unspecified, so I will just put it as a ball, or and yeah, and here entry as a patch, or pressure inlet. So it will change according to the solver which you are using. If you are using OpenFOAM, then it will give the C type of OpenFOAM. If you are using ANSYS, it will give the ANSYS type. So exit, it's pressure outlet. So like that we can do. So, and then after that, after close it, file, go to file, then export and export C, then this file will be generated. Thank you. Thanks so much.